We're going to look at the rectangular coordinate system. All right, so just as a little review, if we have ordered pair, the first number is the x, the second number is the y, and the x tells you to go left or right. Since this is a positive 2, we're going to go right 2 units, and then the y tells you to go up or down. If it's positive, we go up 3 units. And that's always from the origin when we're plotting points. So I start at the origin, I go up 2, or I go to the right 2, and then up 3. And there's my first point at 2, 3. All right, and so for this one, since it's negative, we're going to go left 4 and then up 6. So we go over to 4 and up 6. There's my second point. And then we can go left or right 0 here and then down 2.5. So there's my next point. Okay, so from the origin, when we're plotting points, the x tells you left or right, the y tells you up or down. So now let's talk about the distance between 2 points. All right, so if we're looking at the distance between the 2 points here at -3, 1, 2, 3, and down 4, -3, -4, and the point 3, 0. So if I want the distance between those, notice here that I can always make a little right triangle and then use the Pythagorean theorem. The Pythagorean theorem says that the sum of the square of the short sides is equal to the diagonal, the hypotenuse squared. And that hypotenuse, that diagonal, that is the distance that we want. So if we have a squared plus b squared equals c squared, this c squared, that's the distance, and that's what we're looking for, is the distance. Okay, so the distance formula, notice right in here is the square root, because if we took the square root of both sides, we would get c is equal to the square root of a squared plus b squared. And these a's and b's, that's the length of each of these short sides, okay? So let's look at just how to do this without having to necessarily graph it. Okay, if I'm given 2 points, I have an x and a y from my first point, and then I have an x and a y from my second point. So those little 1s and 2s are just designating which point we're talking about. Okay, the distance is equal to, what we do is we take, here we need x2 minus x1. I just think, where did I get to? For the x, I got to 3, minus, where did I start? A -3. You can square that up. And then that's the length of one side, which here 3 minus a negative, that's 3 plus, that is 6. And here, when we look at the length of our triangle, if we got to 3, that's 3 units here. Well, where did we start? At -3. So the difference between that, when you have 3 minus a negative, that gives you that full length of 6 there. All right, and then we do the same thing with our y's. Where did we get to? Well, we got to 0. And where did we start? At -4. So it's always, where did we get minus where did we start? Minus a negative is positive, so that ends up just being 4 squared. And you can see here that length of that side, even though we're down at -4, if we're just talking length, length is a positive value, so that is 4 units. Okay, so we've got the distance is the square root of 36 plus 16, which is 52. And then we could simplify that as 4 times 13. So the distance, the exact value for the distance is 2 times the square root of 13. And then if you just plug that into your calculator, that's about 7.21. All right, so that's the distance formula. Okay, let's look at an example where the numbers are have some radicals in there as well. So I'm looking at my first point, I have x1, x2, y1, and my second point, I have x and a y for the second point. All right, so the distance would be the square root of the difference in x's, so where did I get to? Negative square root of 3 minus, where did I start? -6 square root of 3. And then we take and square that length plus the difference in y's. Okay, so 2 square root of 6 minus, where did I start, which was square root of 6. And we square that side length. Okay, so let's see, we have a negative square root of 3 minus a negative, that would be negative square root of 3 plus square roots of 3. Okay, and that's like a negative 1 square root of 3. So that would be 5 square roots of 3, quantity squared. Okay, and let's look at this one. 2 square roots of 6 minus a square root of 6, that's like minus 1 square roots of 6, so that gives me square root of 6, quantity squared. Okay, and so here the square root of 6 times itself, so quantity squared would give me square root of 36, which simplifies down to just plain 6. And remember that squaring undoes the square root, those are inverse operations. Okay, and now here I would get 25, and then square root of 3 squared is 3. So then that would give me 75 plus 6, which is square root of 81, and that is 9 for my distance. The other formula that we need to look at is the midpoint formula, and that is given here by, it's basically the halfway point, the average of the x values and the average of the y values. Okay, so we look at our points. We have an x and a y from the first point, an x and a y from the second point. So the midpoint would be, you just add up your x's, so we take our two x's and just add them up. Negative 1.8 plus 4.5, and divide that in half. Add up your y's, so negative 3 plus a negative 1 divided in half. Okay, so now negative 1 plus 4.5, that is 2.7, and negative 3 plus a negative 1 is negative 4. And then when we divide 2.7 by 2, we would get 1.35, and then negative 2. So our x value is 1.35, and our y value is negative 2. And if we look at a picture of this, we can kind of verify that that makes sense. All right, our first point was at negative 1.8, so back about here, and then negative 3. So there's our first point. And our second point is 4.5 and negative 1, so we're right about there for our second point. 4.5 and negative 1. And if we're looking at the midpoint, really halfway between those, this midpoint is at 1.35 and negative 2. So there's our midpoint. Okay, so midpoint, you would add up your x's and divide them by 2, and add up your y's and divide them by 2. There's the midpoint formula.